So you've got an API response jammed into a JSONB column. Could be an array of line items, tags, events, whatever. You need to query it like it's rows, but you really don't want to loop through it in your application code.
Yeah, Postgres has functions that'll explode those arrays into rows right there in SQL. We're going to run them against a real payload, then talk through when you should actually normalize this stuff versus just leaving it as JSONB.
All right, first up, use the function JSONB array elements in the from clause to expand a JSONB array into a set of JSONB values, which can be treated as rows.
So JSONB array elements takes a JSONB array and spits out one row for each element. The result is JSONB, which means you can chain operators like single arrow to extract JSONB values or double arrow angle bracket to extract text.
And if your array is just primitive values, strings, numbers, you'd use JSONB array elements text instead, right? That gives you the text representation of each value directly.
Yep, saves you that extra cast step when you already know the elements are scalars.
Let's say you've got a JSONB column that stores an array of strings. You can explode it in one select. Here we're using JSONB array elements text on a literal JSONB array.
And you get 3 rows back, 1 per tag. Now picture that column living in a table. You'd write select ID, JSONB array elements text tags from articles, and every article with n tags produces n rows.
So if you join that or group by the tag, you're querying the array like it's a normalized many-to-many table, all in SQL, zero application code.
Okay, when your array holds objects with known keys, JSONB to record set is what you want. It expands the outermost JSONB array of objects to a set of rows, and you specify the column names and types.
JSONB to record set expects an array of JSONB objects, and you tell it which keys to extract as columns, plus their types. It's basically schema on read for JSONB.
Right? And if a key is missing in one of the objects, you just get null for that row. If there's an extra key that's not in your column list, Postgres ignores it.
So you get type safety and a clean result set, even if the JSONB is a little messy or evolving over time.
Here's a realistic case. An orders table with a line items JSONB column holding an array of objects. We call JSONB to record set and define SKU as text, QSI as int, price as numeric.
And you get back 2 rows with proper types. Now you can do things like sum the price, join on SKU to a products table, or filter where keyword is greater than 1, all in SQL.
No marshaling into application structs, no loops, just a function call in the from clause.
A few patterns show up all the time. First, if you want to keep the parent row's ID alongside the exploded items, use a lateral join. That way, each line item row carries the order ID with it.
Second, you can aggregate across the record set, cum price times quatch y to get the order total, or count distinct SKU to see how many unique products. Third, always filter the parent table first if you can. Exploding a million rows is expensive, so throw a where order date is greater than something before the lateral join.
And if your JSONB is nested, say an order object with a line items key, you'd use the single arrow operator to extract that nested array, then pass it to JSONB to record set.
One more thing. A gin index on the JSONB column helps with containment queries, like where payload contains some filter. It won't speed up the record set scan itself, but it'll prune rows before you explode them.
By the way, if you're doing a lot of JSONB queries, my DBA's free health check will flag missing gin indexes on those columns and give you the exact create index statement. No guessing.
All right, so we've seen how to query JSONB arrays like tables. The big question is, should you actually normalize this data into real rows or leave it as JSONB?
If your data is truly document-shaped, the array is always read and written as a unit. Schema varies per document, and you rarely filter or aggregate across items. JSONB is great. You get schema flexibility, atomic updates, and simpler application code.
But if you're constantly joining on item attributes, aggregating across all items in all orders, or enforcing foreign keys to a products table, normalize it. You'll get proper indexes, constraint enforcement, and way better query performance at scale.
Yeah. Rule of thumb. If you find yourself calling JSONB to record set in every query, or you've got a gin index and it's still slow, that's a signal to normalize.
And you can always do a hybrid. Keep a summary JSONB for fast reads, but also write the critical fields into a real child table for complex queries. Best of both. Here's a quick checklist. If you're doing frequent joins on item attributes or aggregating across all items, normalize. If your schema varies per document and you rarely query inside the array, JSONB.
If writes are transactional units, like an order with its line items always updated together, JSONB makes it simpler to update the whole array in one statement. But if you need foreign key constraints, cascading deletes, or referential integrity, you have to normalize. JSONB doesn't enforce that.
And performance. At small scale, JSONB with a JIN index is fine. But once you're scanning millions of rows and filtering on nested fields, a normalized table with a B-tree index will crush it. JIN index is great for containment, not for range scans or equality on a single field.
So the answer is, as always, it depends, but now you've got the tools to query JSONB like rows while you figure it out, and a clear checklist for when to pull the trigger on normalization.
One more function for completeness, JSONB populate record set. It's similar to JSONB to record set, but you pass a null value of a specific composite type as the first argument. Some folks find it cleaner when defining complex types.
Yeah, and if you've already got a composite type defined in your schema, you can pass null : that type, and it'll map the JSONB keys to the type's fields automatically. Saves you typing out the column list every time. So whether you're exploding JSONB arrays or querying normalized tables, indexes matter. My DBA's free health check connects to your database, spots missing and unused indexes, and hands you the exact create index or drop index concurrently commands, no guessing.
It's free, it runs continuously, and you'll get a full report graded across 16 domains in about a week, with fresh reports every week after that. Head to my dba.dev, connect your database, and see what it finds. Thanks for watching.